Welcome back. Today, we're doing a deep dive into something very specific. We've got the technical specifications for a commercial environmental monitor, the NTI E-GD-MBP-P gas detector.
Exactly. And our mission here is really practical. If you're the one deploying this hardware, you need to know its limits fast. What are the functional thresholds? How does it plug into the wider system? That's what we need to distill.
Okay, so its primary job is, well, it's continuous air monitoring. It's sniffing for the big four combustible gases: methane, propane, butane, and acetylene.
And if it finds them, believe me, you're going to know about it.
You certainly are. The audible alarm is specified at 94 decibels at a distance of 1 foot.
And to put that in perspective for you, 94 dBE is louder than an average lawnmower. It's really designed to cut through the ambient noise of a busy data center or some other industrial space.
Right. Now, here's where the source material gets really interesting for me. The installer gets a huge operational choice. You can actually select between two distinct detection levels.
Yes, and this is the core decision point. It's basically a risk tolerance dial built right in.
So let's break down the numbers. What are we talking about for level 1?
Okay, level 1 is the high sensitivity setting. For methane, it trips when concentrations go over just 0.5%.
Just 0.5%?
0.5%. And for propane and isobutane, that threshold is even lower, down at 0.3%.
And just for context, the industry standard lower explosive limit for methane is what, around 5%?
It is. So this level 1 setting is designed to catch a leak long before it becomes a measurable threat.
It's a very, very early warning system.
Precisely. Now, level 2,
Yeah.
that's the less sensitive setting.
Okay.
It raises those thresholds quite a bit. Methane detection requires concentrations over 0.8%, and propane needs to get over 0.5%.
Which, of course, brings up the obvious question. Why would anyone choose the less sensitive setting?
Nuisance alarms. It almost always comes down to that.
Ah, I see.
In some industrial environments, you might have low-level gas venting as just a normal byproduct of an operation. So you'd opt for level 2 to make sure the system only activates for a genuine leak, not just trace amounts in the air.
That makes perfect sense. So that's the detection side. What about connectivity? How does it actually integrate into a system? What does it need to run?
It needs very little, just 150 milliamps at 12 volts DC. It's powered by specific NTI units, the E2D, 5D, or 16D. So that low power draw is a big plus.
And I see it's both CE approved and TAA compliant. That TAA part is pretty key for government or institutional buyers, right?
Yep, absolutely. It means it meets the U.S. Trade Agreements Act standards. It's a requirement for a lot of contracts.
The specification that really jumped out at me, though, was the maximum cable length, 1,000 feet.
305 meters, yeah. It's genuinely impressive.
But how do you maintain signal integrity over that kind of distance? Don't you worry about voltage drop?
Well, that spec tells you the internal circuitry must be incredibly robust. It's designed for that. It means you can wire up a huge facility without needing costly signal boosters partway through the run. It saves a lot on installation.
And the electrical output seems just as versatile.
It is. The relays are level selectable, so you can configure the output as normally open or normally closed.
And it can handle a decent load?
A very decent load.
Yeah.
It's rated for a max of 5 amps at 250 volts AC. That means it can interface with pretty much any control panel out there, even older systems that need more power for switching.
So it's ideal for retrofitting.
Exactly.
All of that is critical for a device that comes in at $420, and that includes a 2-year NTI warranty. And we saw in the sources that this isn't a standalone product. There's a whole line of these things, like a carbon monoxide detector, liquid detector.
It's a whole structured ecosystem for environmental monitoring.
So connecting all this back for our listener.
If we do that, I think the real takeaway from this deep dive is this final thought. Understanding the difference between a 0.5% and a 0.8% detection threshold. That can mean the difference between a minor alert and a full operational shutdown.
A huge difference.
So you need to ask yourself, why might my specific installation want that less sensitive level 2 setting? Why would I deliberately sacrifice that early warning for operational stability? That's where you apply this technical knowledge.